Hello, everybody, and welcome to today's webinar, Transform Your Enterprise Data Operations with Data Observability, brought to you by Acceldata. I'd like to introduce to you our presenters. We have Sanjeev Mohan. Sanjeev is an established thought leader in the areas of big data and analytics. He advises on changing trends and technologies in modern cloud data architectures. Until recently, he was a Gartner Research Vice President. He regularly presents on topics pertaining to end-to-end data pipelines. Also with us, we have Rohit Chaudhry. Rohit is the CEO of Acceldata. Prior to Acceldata, Rohit served as the Director of Engineering at Hortonworks, leading the development of data plane services, Core, and Embari. At Hortonworks, he was inspired to start Acceldata. He repeatedly witnessed customers' multi-million-dollar enterprise data initiatives fail due to using inadequate data technologies. Both of you, welcome to today's webinar. Thanks for joining us.
Thank you so much.
So before we get into a presentation, I wanted to ask a couple of questions, and they're for both of you. So we'll start with, well, this question will be for both of you, for Sanjeev and Rohit. Multi-dimensional data observability is a relatively new term. Can you guys talk about what it is and the need for it? And we can start with Rohit. Rohit.
Sure. So, if you look at what has happened in the last decade in the, the realm of data technologies, what you find is, distributed computing has literally taken over. Every single company has more data than ever before. They are trying to become data-driven. And one of the things that they are finding out is that, operating these complex distributed data systems at scale is a very, very painful task and job. So, just like you mentioned in the introduction, when I was at Hortonworks, I used to find that large enterprises would struggle to build and operate and scale their data systems when it came to really voluminous data, coming from different kinds of sources. The other challenge that is associated with that is that, the most precious resources of your organization, which is data engineers who are responsible for building these business, revenue generating business use cases, they're finding it very difficult to sort of focus on their core area of expertise and build new use cases. They were indeed spending a lot of time in just making sure that, the data systems are operating perfectly and in the way that was assumed in order to deliver the ROI that was promised from these data initiatives. What we figured out, as this was as insightful as it could get, was that, the big five, which is the Facebooks, the Apples, the Netflix, and many other companies, they've actually invested in data management practices and built their, multidimensional data observability tools, which allow them to get the right level of insight into their operational systems at production at scale. Unfortunately, 95% of the enterprises don't have access to those kind of systems. Now, what you actually need is the understanding that data is going to go through a journey from the point of origin all the way to the point of consumption, and that's a very, very long journey which goes through several different interconnected systems. So when people are trying to look for cues and clues within operational issues, whether it happens with regards to data quality or an SLA which is missing inside the data pipeline, or within the underlying compute frameworks which are being used to transport data from the point of origin to the point of consumption, you will need multiple points of data and information in order for you to be able to accurately determine the cause of the issue and potentially, even to prevent these issues from occurring in the future. So when we think about observability for the data intensive applications, which is the new domain, quite unlike the APM players of the past, you will find that, customers and enterprises are looking for visibility inside their data pipelines, into their compute frameworks, and the quality of data that is flowing through these pipelines. And that is what we define as the multidimensional observability scenario for today's world.
Awesome, thanks. Sanjeev, how about you? Can you tell us from your perspective what multidimensional data observability is about and the need for it?
Yeah, so thanks, Khaled. Rohit did a great job explaining this, and I just want to dial a bit deeper into why do we even need this multidimensional data observability. One of the reasons is because in the past, when we were building these applications to meet analytical needs of our business units, what we ended up doing was a business unit said, let's just claims department in an insurance company, I need to run some claims related machine learning models maybe, or just reports, dashboards. So I need certain data. IT would create a copy. So we would have redundant data, many copies of data, and we would now get a new silo. Marketing needed different characteristics, same customer data, but their needs were very different. Pharmacy has different needs. You just name it, different parts of insurance companies have different needs. Multiple silos have sprouted up. At this point, no one knows which is the source of truth because there's just so many. So what IT does in the process is IT then creates these complicated pipelines to stitch together all of these silos. Something is bound to break. In fact, it's so common. I talk to these banks, for instance, and it's mind-boggling. They run like 1,000 data pipelines at night because it's like a spaghetti of data going in different directions. But that's a reality we live in. If a pipeline breaks, which it will, that's not a surprise. Now the business team is trying to figure out what just went wrong. So they're spending their time trying to triage what just went wrong. Is this data even trustworthy? So they're now trying to figure out data availability issues, data quality issues. IT, on the other hand, is spending all their time trying to band-aid and run these operations, like overcome these operational challenges. What really needs to happen is that the business and the IT team, they need to be laser focused on all the business strategic imperatives that will get the company the competitive advantage rather than trying to fix these operational problems. So how do you fix it? Well, people say, well, we have monitoring, we have APM, application performance monitoring, we have all kinds of monitoring. The problem is that the monitoring is after the fact. The monitoring will show you with a nice dashboard, here is how your pipeline or your application performed, not even pipeline. But if something breaks, it'll tell you it broke, but where did it break? Why did it break? What is the context? What is the interplay between that application, the infrastructure it's running on, and the context of that data? See, this is where it becomes multidimensional data observability. It is not simply, did the data arrive on time? That's just easy to do. I can easily put some sort of a monitor and I can say last few days X volume of data came in. I'm expecting my trend shows this much should come in. Why did it not come in? But finding that freshness of data is one thing, but trying to understand where in that complex pipeline did that outage happen is a far more complex problem, which needs an understanding of the lineage, how that data has transformed, who is using that data. So anyway, so that's a long-winded answer. Rohit, feel free to jump in, anything you want to add to that.
Yeah, I mean, just one quick point over there. When you're operating these, very complex data systems, what ends up happening is that, you're getting signals from these different layers. Some of those signals are coming from the infrastructure layer, some from the application, and some from data itself. I think what customers and enterprises would benefit most from is something which correlates all of these different signals, because, these signals are coming at varying velocities. Infrastructure signals are much faster than, metadata signals. But once you start correlating these algorithmically, then you can actually identify when actually an anomaly occurs. Is it occurring because of an infrastructure trend problem? Was your network, capping out, or did you have issues in resourcing? Or, did you actually end up paying a lot of money to one of the cloud providers because you were trying to perform a very, very complex compute? So I think, what customers are looking for is a 360-degree view, which is extremely multidimensional in nature, as opposed to just focusing on one element, which in one of the cases could be just data quality. Because, amongst 100 different things that the operational teams are concerned about, data quality could be just one of those.
Correct. And if I may add something to what you just said, Rohit, it's one thing to say, is the data high quality, but what is the cost of building that pipeline? Like, is it really efficient? Did we use the right resources, or did we over provision our resources? See, if you have that view of utilization built in to this entire end-to-end observability, now you can right size and do cost optimization. So these are some of the interesting use cases of data observability. Data quality is one, cost optimization is another one, reliability is another one. If I can predict using trend analysis or something that I have a problem that may happen, then maybe I can prevent that outage or that high severity problem, and keep it going. Now, of course, technology, there is like machine learning models that you can write, but having that end-to-end comprehensive package is what makes it multidimensional.
Indeed.
Awesome. So I think you guys addressed my next question, which was going to be, the difference between multidimensional data observability and your traditional app monitoring tools. But I think we covered that in spades. So I do have one more question before we get into the demo, and this is for both of you. Who in the organization will benefit from data observability solutions?
Yeah, so it's a very interesting question, right? So if you look at what is happening in the modern data-driven enterprise, is that the power is sort of shifted, and the power is actually being put in the hands of the people who are selecting the technologies. And in my mind, the most important team today in a data-driven org is essentially the data engineering team. And those data engineering teams are not waiting for blessings from their VP or SVP or the CTO or CDO before they make the choice of the technology. However, what it does is that over a period of time, you actually accumulate a smattering of technologies, which when heads into production domain and when it starts getting into scale mode, that's when the VP and the SVP and the CTO and CDO, they actually have a challenge. And the challenge is to actually maintain these operational systems at scale. So if you were to if I were to go and draw back from Sanjeev's previous comments, I think data observability is a glue that actually allows you to connect three different groups, which is essentially data engineering, which is building these new revenue generating business use cases and implementing, adopting different kinds of technologies and putting all of that in play. But it is also very useful for the operators, particularly in IT, DevOps, and DevSecOps, the people who are actually responsible for keeping these systems up and running all the time. And finally, it actually puts together the third element or the third leg of the stool, which is business itself. One of the things that's changed, in addition to this massive shift in the way technology is getting selected, is also the advent of, actually two large trends. And there is a backdrop to what is going on over here. The first trend is the adoption of open source and open core within the enterprise. And the final trend is that business users are actually getting much more closer to technology, because for them to succeed, they're still required to understand how these pipelines behave. When is it that they can expect certain answers, and when is it that they should raise alarms? So I think what data observability does is that actually it puts a very good glue around which all of these three teams can come together, and it then gives them a comprehensive way of understanding their data systems better. And it provides tremendous outcomes from a business point of view.
Khaled, I was in an event and same question came up. Interestingly, 50% of the audience said it's a top-down, and the other 50% said no, it's a bottoms-up. So I think if I were to do a logical and, I see this, Rohit, sorry if I'm digressing here from what you just said. To me, different, if I look at top-down roles, different leaders in data and analytics space have different requirements. I've got a CDO that wants to know, is my data governed? And like if I have a GDPR like issue, that's what data privacy officer cares about. A CISO cares about, if there's a security breach, how do I know where in the pipeline did, was it a misconfigured bucket, or was it, somebody joined the data incorrectly and re-identified the data? So you see, there's a lot happening here. So the analytics of business people their end goal is to have that agility to run these reports and not get slowed down by all of these processes. So I see that, I would say the primary beneficiary of data observability started as the data engineers, but it has grown into becoming like the glue that makes my modern data stack hum. So there are now many, like, they say a failure has no parent, but a success has many. So I think this is what we are seeing in data observability. Everybody now wants to have a reason to participate in it, and this is the reason why you see data observability is one of the hot subjects these days, because it has so many use cases.
Yeah,
Oh, go ahead.
Just one, additional point to that, Sanjeev made some really interesting observations over there. So I think, there's no conflict between, how technology is getting selected and how it is getting or being put into production from a selection point of view. I think the objectives of both the data engineering teams and the objectives of the execs are very well aligned. And I think both of them will benefit, tremendously by adopting things like data observability. It's almost like saying that, we are now undertaking a journey of data which is going to be extremely long and in many cases tiring as well, and therefore let's get better navigation. Just an equal of Google Maps, you need observability which tells you, are these selections of technologies wrong, or is the implementation wrong, or do we have simple resource outages, or do we have a lack of information, understanding, and expertise in certain technologies. So it could be a combination of all of those. But it's a good navigation map to have if you really want outsized ROIs, just like some of the large internet companies.
Like one last thing, then we can move on to a demo. Like one of the use cases I did not mention, and to Rohit's point, is what does the CIO or the CTO care the most about? Is, do I have the most efficient IT infrastructure to deliver what the business wants? So cost is a very big thing. And the CIO may be saying that, we've outgrown our on-premises environment, we want to move to the cloud. How am I going to move to the cloud if I don't have the right metrics on how my current system is performing? Because that will dictate what infrastructure do I need in the cloud. So that becomes another data observability use case.
Awesome.
So with that, I think back to you.
Oh, I was going to say, so I think the discussion around this is great, and I think what the practical next step here is to see what Acceldata can do to help people realize some of these benefits.
Yeah.
Yeah, indeed. I'm actually looking forward to this demo session. So what I'm going to do is actually walk through a few slides and then actually shift very quickly into a demo, and probably take about 10 minutes overall between both slides and demo, and hopefully this will be useful. And then we can come back and have another discussion around the demo and the features that we see. So just a brief introduction, from a company point of view. These are some of our customers. We are privileged to work with Oracle, HealthEdge, Pratt & Whitney, and many other top Fortune 50 customers in the US and worldwide. At this point in time, we have customers in 8 different countries. We are over about 100 people, getting closer to about 120 actually. We just closed our $35 million round last week, and we made the announcement for that. And most of our leadership team comes from enterprise companies, particularly from the background of data. We've myself and 3 of our founders come from Hortonworks. We also have a bunch of other people who joined us from Adobe, Citrix, and some of our leadership also includes people from Gartner. So it's actually a fairly good team. Some of the earlier discussions that we were having in terms of why data observability is required, I think this slide just tells people why is it so necessary. Because if data is going to power the enterprise, then the grid has to be reliable. The challenge is that the grid is getting powered through different kinds of energy sources or different kinds of data technologies. And the challenge is that the number of data technologies that you have to be successful with simultaneously is going up and up and up with every change of year. Dare I say year, because what I'm seeing is that every quarter there's one new database which is coming up, And every 2 quarters, I'm seeing that one database is actually truly taking off in the real sense of the word, which essentially means that people are starting to put workloads into production with a database or a technology which does not have the 30-year-old backing of an Oracle. And what it does is that it actually shows the limitations of these use case specific purpose-built databases. And that is the real challenge that enterprises are facing. So what ends up happening is that, while you've adopted that successfully for a couple of use cases, there are more use cases that business is bringing to these data systems. And when you try to, operate that at scale in the production environment, you end up with issues which include, unmet SLOs, unmet SLAs, and, most of these problems end up at the doorstep of the engineering. Because if you just for a moment spare a thought for site reliability engineering, what it has had to do in the last 10 years is that, it had to extricate itself as a permanent discipline. But now what they're facing is that they have to go and figure out all of these different data technologies, and they're not very well adept at those technologies. Now, when you hit these production issues, when you're slow on adoption, when you're unable to onboard new business use cases because your data engineers are actually working on day-to-day production issues, the ROI that you expected with your data initiatives, it's actually quite behind, and you don't seem to see the impact that you actually hope to. So what are customers doing today? The view of the world is as follows, that customers are looking at previous generation application performance monitoring tools, which was really good in the before world, where you had applications which were reading and writing to single databases and reports were getting published to execs once a week, versus today, where 90% of the data teams are actually dependent very, very operationally, not just analytically. Analytical views are essentially looking back and trying to find out what happened in the past. Operational views are real time. For example, Uber dashboards. If Uber's streaming system goes down, then you won't be able to do a match between a rider and a driver, and which essentially means that Uber's network is all of a sudden down. If you go to Netflix and if the recommendation system stops working, then Netflix won't be able to drive viewership on certain titles, which it would otherwise, at 9 p.m. in the night in the US. So what ends up happening is that, now there are these mission critical systems for which the previous generation application performance monitoring tools are not sufficient, because the previous generation application performance monitoring tool was responsible for giving you details when you had a single database or a few of those databases, because it was microservices based architecture. But the challenge with that is that it does not scale for the kind of environment in which data is coming into the enterprise today, and the number of use cases that it is getting applied to. So the same data is getting applied to machine learning, dashboarding, reporting, custom applications, and many other use cases. And for that whole plethora of use cases and the volume of data that exists in the enterprise, the application performance monitoring tools are insufficient. So we actually built this company, and in 2018, when we started working, we figured out that the whole world of open source and distributed technology is only going to grow. Enterprises will have to adopt to stay competitive and continue to exercise influence in the market by bringing new use cases such as recommendations and personalization. The challenge was you needed something which gave you multidimensional visibility, which we actually spent so much time on. So here's a schematic which shows you how the previous generation application performance monitoring companies exist and how the newer companies are actually tackling a lot of problems which we just spoke of in such great detail earlier in the conversation. But what we really differentiate with is actually the multidimensional visibility across compute infrastructure, data pipelines, and data quality, all in one. So if somebody uses Acceldata, they don't have to look for yet another solution to manage and operate the data systems. Key problems, just recapping, and then we move on to a demo very quickly. Operational pains, innovation pain, and budget pain. Those are three big problems. Okay, all right, so I'm ready to go. So what I'm going to show right now is essentially, so as part of the demo, what we have right now is essentially the representation of a data pipeline, which is very, very common inside a modern data enterprise. What you see over here is that this is a fairly simple data pipeline, which shows how data is getting created inside an S3 location, written down to RDS. And then we use a Databricks job to move all that data back into Snowflake. So essentially, Databricks is being used as the ETL tool. Snowflake is being used as the final repositories, and then there are files in between. Now, as you can see, this was expressed in Airflow, and we've provided our SDK for integration over here, which allows data engineers to go and log all the critical events that they would like to log, and in addition to that, create the events that are of interest that may be useful from a production and operations point of view. What we do inside the product called Acceldata Flow is essentially represent the same data pipeline, but make it data aware. So if you look at this, the red boxes are essentially representing all the different compute jobs, whereas all the green boxes are essentially representing all the data elements that are associated with these compute elements. And as you can see, these are essentially the intermediate RDS tables, while these are the S3 locations where we are creating these jobs, which are then finally getting merged, and we are creating a table out of it. If you look at what else we have on the screen is essentially a representation of how much time did this pipeline take on an ongoing basis, repetitive views of how it has been doing from a performance point of view, if there were any failures, when was the last time that this pipeline failed and what were the causes, and if you wanted to do a comparative analysis, you will be able to see the reasons why some of the pipelines have slowed down, and you can go back in time as far as you can go. The other thing which is very interesting is that we allow developers, data engineers to go and log all the information. So now, as you can see, there's a complex data pipeline, which is a multi-technology data pipeline, which is moving data, from the point of consumption, or point of origin to the point of consumption using different technologies. We have log information available, which shows what are the errors which occurred along the way. Any information about metadata, all the different, information details about what query ran, what time did it start, how much time did it take. So all the operational details are available right here. In addition to that, you also have the capability of not just looking at the operational details, but you can also start looking at, what data was processed. When was this data last profiled? What kind of data policies were configured? Was the reconciliation policy configured on that data element or not? Is there a data drift policy? And is there a warning that we can see from a data drift perspective, looking at, is the data the same that we had assumed it will be when we were either training our models or creating these analytical reports or operational reports for people to go and consume? And if it has changed, how has it changed? And that detailed view is available inside the capabilities that we have provided inside, Acceldata Torch overall, which gives you not only the view in terms of, what data elements exist, but, in a complete 360-degree fashion, which talks about not just profile, it also tells you how the data quality is, talks about things such as automated anomaly detection, and gives you an entire or a complete view in terms of what data elements are you using today. Now, one of the things that I am going to cover is where did this data come from? But before that, let's look at things like quality. Now, as you can see, this particular data asset has two kinds of rules configured against it. One is essentially a simple rule which says that whether data is changing or not. So as you can see, no data elements have been added, the DMLs have not been applied. But if you look at where it is receiving data from, as we just saw from the pipeline, this data table is receiving data from several other data sources, and we're trying to do a reconciliation between the amount of data that it should receive versus the amount of data that it actually has received. And as you can see that from an equality point of view, this has been consistently failing. Now, every time a failure occurs, the same error message is sent over different channels, which are very operational friendly. You can essentially configure it using Slack channels, Jira messages, Inbox, ServiceNow, or you can actually integrate with API. So one of the critical elements of our differentiation from a product point of view is that the entire feature set, everything that is visible here and more, is available via APIs. So one of the things that we are encouraging data engineers to do is to actually go use all of these APIs and integrate inside their own data pipelines and use all of this information to build circuit breakers, which allow them to manage and monitor their data pipelines a lot better than they would otherwise. In addition to that, we've got things like automated anomaly detection. So you don't have to actually configure quality rules. We automatically understand the trend and the pattern of data. And we tell you that, here is where we feel that, you have had data elements which don't fall into the bracket that you assumed it will. And therefore, you should actually consider looking at these data elements, even when you assume everything is okay. We've already identified that there have been anomalies. In addition to that, identifying what are the different relationships in which it occurs. Where is the data asset placed? What is the provenance? What is the lineage? Where does it exist in a physical space, in a logical space? What kind of lineage can we look at? For example, where was this table created from? Now, just like we saw earlier inside Acceldata flow capabilities, that the data pipeline, the processing pipeline is data aware. In this case, the lineage is processing aware, which is a very, very unique feature that only Acceldata provides as of today across a host of different vendors. So what we have over here is that not only does it have the view of where, what the antecedents or what the provenance is, but it also tells you about, which jobs ended up creating, this complex hierarchy of tables. And, as you can see over here, it clearly says that, the data quality is failing. So in one view, you get the entire picture. Now, the final part of the demo is actually about monitoring, how you're doing in terms of your compute infrastructure, which we were talking about. The compute infrastructure actually can talk about, since we're talking about, jobs which are Databricks specific. If you wanted to look at the Databricks job, which was used in order to create this particular table, you can actually click on the details of that particular job and look at how has it been performing historically. From a comparative standpoint, whether these jobs have been running on the Databricks infrastructure in the right amount of time, if they were configured from a concurrency point of view with the right number of executors, did it have the right ideal time? Did it use the right amount of cores? Did it have the right amount of processing power? How was it scheduled? How did the executors run? And most importantly, were we using the cores in the right way? Because Databricks is pretty expensive, and so are several other compute infrastructures. But are you spending the right amount of money at the right place? So finding out to the final level, which is what we were speaking about earlier, is finding out whether you were able to identify through a correlation mechanism, starting at the data pipeline, going all the way down to the infrastructure and compute level, and finding out whether the entire data pipeline was functioning appropriately or not. So with that, I think we've concluded this demo, and we can obviously get into a lot more detail because we have got a lot of content to publish from a compute framework or from a data quality or a pipeline perspective. But for the purpose of this demo, I'll just stop here.
Rohit, what are some of the data sources, data engineering products that you support?
So we actually support a host of different technologies today. For example, we support approximately 24 different data sources, which are on-premise, on the cloud, traditional historical data warehouses, stable RDBMS systems such as Oracle. We support all of these technologies, and we're adding integrations at a rate and scale that is very, very encouraging for us. But we are basically present across the modern infrastructure. We are also present across the on-premise infrastructure.
That's great. So you got legacy databases here, like you've got cloud databases, you got ETL engine, you've got BI reports. So this is what's letting you connect, where the data originated in, let's say, Oracle, and how Databricks processed that data, landed in Snowflake, and how Tableau visualized it.
Indeed. And that has been the thesis of the company, that we've got to go right from the beginning all the way to the end. And the end may be the case that a business user is actually accessing reports on Tableau or Looker, but they seem to have the same issues that a data engineer might be grappling with, because he found that the data pipeline failed. Fundamentally, they're looking at the same issues, and therefore we feel that there's like a unique experience which is uniform across these different sets of users, which actually provides them a common vocabulary against which they can actually start producing results.
Right, makes sense.
Kenneth, back to you.
Awesome, thank you. Thanks for the demo. I have a couple of questions just to follow up your demo that people who are watching this may have at the time they watch it. You mentioned a couple of different things in the demo that you say are core differentiators for Acceldata. And we talked quite a bit about the kind of multi-dimensional nature of Acceldata, Would you consider that to be your secret sauce? Like, what is the secret sauce to Acceldata?
The secret sauce is, the ability to correlate signals across, infrastructure, data, and application layers and present all of that in a single pane of glass. I think that is our biggest differentiator. The fact that we are able to, stitch together all of these signals, which otherwise, customers and enterprise teams are struggling today to go and find. I think, that is our secret sauce. We're basically taking out the friction from a very complex operational process.
Well, that leads right into my next question, which is, when we talk about implementing tools like this particularly for ops teams who have a million things going on, somebody who's watching this may wonder, how long does it take to implement, and how long does it take to actually see value from implementing Acceldata?
Yeah, that's like, one perennial question that we keep getting all the time. And, from my own experiences of, building enterprise products for the last 15 years, we learned some hard lessons, took some hard knocks, and we decided that, we are at this stage going to be very, very light and, frictionless in terms of our onboarding, making sure that, we are able to reach, customers, reach and meet customers where they want us to meet and reach them, which is, at their choice of infrastructure in the method of deployment that they're comfortable with, in a model that suits them. So we're essentially trying to be native from a technology and platform point of view. So if you're on premise, you should be able to get the system up and running in 45 minutes. If you're on cloud, then the expectation is instantaneous. So we're trying to cater to those SLAs from a deployment perspective. From a value standpoint, some of our largest customers have actually over a period of time, they've actually found tremendous benefits into the solution. Some of our largest customers have not had a severity 1 incident ever since we deployed way back when in 2019. So we've been running their infrastructure components without any issues for the last 2 years, which is a big deal when companies are trying to get successful with data.
For sure. And you talk about kind of being tailoring the approach for each customer. So every customer is on a different part of their data journey. And Acceldata seems very feature rich. So when somebody comes in and they buy the product, do they take all the features and they use some, or they don't use some, or can they kind of choose a la carte based on what they need?
Well, so different customers use certain capabilities at different points in time. It actually depends upon the enterprise data journey, because some customers are further along and they need more capabilities. In some cases, the customers are actually not that mature, and therefore they start with a sliver of the capabilities that we're talking about. But over a period of time, they end up adopting most of our technology. So one of the things that we've seen very commonly across our customer base is that they start with either infrastructure or compute monitoring, and then they head into higher level elements, which is monitoring data quality, ensuring that they have the right level of access, and ensuring that they're able to govern their data from an operational concern point of view, as opposed to just a governance initiative. So over a period of time, what we see is that we made the adoption of different capabilities very, very frictionless, and at full scale they use all our capabilities.
Awesome. So I've got one last question. This one's for Sanjeev. As we talk about data observability, some people may be learning this for the first time, learning of this concept for the first time. Some may be familiar with it. When should somebody start to think about data observability in their data lifecycle?
Yeah. So, Khaled, you mentioned that for some people this is a new concept, a new term. Observability as a term has existed for a very long time, but it was primarily used on the infrastructure side. Now we are taking the same lessons learned, and this is, to me, this is the gradual transformation that we have seen in the data management, whereby we are adopting the DevOps best practices. On the application side, we started doing DevOps like 10 years ago, but it's taken us such a long time to get to a stage where we can apply the same thing. Some people call it data ops, but whatever we call it, the reason why we are now seeing an increased level of emphasis on data ops is because it's taken us a long time. Data is always changing. Applications change, yes, but they don't change all the time. So we are now in a very interesting spot where the technology has caught up. I think anyone who is in the process of modernizing their environment, whether you call it digital transformation or modernizing your data stack, they should definitely have data observability as one of the items that they should evaluate. And they should see, what are the capabilities, how do they map to their requirements, and it's another topic, by the way, I cover is data governance. Same problems happen in data governance where people made data governance an afterthought. They said, we don't want things to slow down. Let's just build this new architecture, and then we will come back and figure out data governance. And we know that doesn't work. We don't want the same mistakes to be made for data observability. It should be part of your proof of concept for your new environment, and even the existing ones.
Awesome. I think that's super helpful for anybody watching. So before we wrap up, I guess I do have one more question. Rohit, if people want to learn more about data observability, they want to learn more about Acceldata, what should they do?
So, read the blogs that we put out, on a regular basis. We've got some really incredible white papers and, more content coming. There's like a bunch of demos that you can sign up for, and our teams will actually reach out and explain why data observability is so important. Another thing that is of interest to a lot of our new customers is essentially the case studies that we published and the kind of benefits that they've received. But I think this is a phase where there's like a lot of material coming out from a data observability standpoint, from an industry point of view. And I think some great content is about to reach, these enterprise customers. So I think this is a good phase for, just educating and bringing their own knowledge base up to speed and finding out, which use cases merit the most amount of importance and, their attention right now.
Great. So yeah, you heard it from the man himself. I'd like to thank both of you for just spending your time to introduce our audience to these concepts and provide a demo. Super exciting stuff, and I encourage anybody who's watching this to go to Acceldata's website or reach out to Rohit or anybody from his team. Thanks again for your presentation, and we will, I guess, wrap up there.
That's great. Thank you so much for having me.